So in this lesson, we're going to be working with those same formulas that we learned that are on the reference sheet from last lesson. A lot of these problems we're going to have to solve for something versus just plugging in. So it says an investment of $300 is made at 3.6% yearly interest compounded continuously. So I see these words and that tells me that I'm using this formula from the reference sheet. My first question says, how much is the investment worth after 10 years? So we have our t value, we have 0.036 for r, this is our p value. So on this one, we're actually not solving, we're just plugging in. So I have 300, the number e, 0.036 times 10. And I'm going to go through these pretty quickly, suggesting to try some of them on your calculator on your own. So that gives me $430 to the nearest dollar. Looking at the next one, now we have the same formula, and it does give me a hint. When it says algebraically, usually I have to do some sort of specific type of solving. Algebraically determine the number of years, so I'm trying to find t. It will take for the investment to be worth, we'll typo there, $800. So we have 800 is what my amount at the end I want to be. My start number is the same problem, is still 300. My r is still 0.036, and this time I'm looking for the t. So a few lessons ago, we practiced solving these, same idea. We want to first divide by 300, and that is going to give me approximately 2.67. At this point, I have a base, I have an exponent, and I have a number. Base, exponent, number. So I'm ready to put this in log form. So I'm going to start, instead of writing log base e, that's always, as you go on further in math, referred to as ln. So if I decide I want to write log base e, which is what I have for this problem, I'm just going to write ln in its place. So I have ln of the number, which is 2.67, equals 0.036t. If I type in ln of 2.67, using the whole number I had, so 2.6 repeating, that's going to give me approximately 0.98. And if I divide that whole number by 0.036, my t value for this one is the nearest hundredth, 27.25 years. Looking at the next problem, we're first trying to figure out what type of formula we have to use. It says the population of a town with 12,500 residents is decreasing at an exponential rate with a half-life of 17 years. So from that information, I know that I'm using my half-life formula, and from my reference sheet, I know that that is this. So I have my start number. We know a sub 0 is the start number, similar to p. They just, for some reason, use a sub 0 on this one. My 1/2 is just a number. They're asking me when, so I'm looking for t, and they tell me the half-life is 17 years. We're asking when it will reach 5,000, so the a is our final amount, so that number goes there. So we're ready to solve. So we divide again to get towards bend form. That gives me 0.4 equals 1/2 to the t over 17. Unlike the last one, this doesn't have a base of e, so I use the regular log. So my base is 1/2, the number is 0.4, and the exponent is t over 7. Typing this in my calculator, I get 1.32 equals t over 7, and then multiplying by 7 on both sides, I end up with t equals 22.5 years. And the next one, it says a virus is spreading such that the number of people infected doubles every 4 days. So this is the one formula that we talked about in the last lesson that you're not given, and that's doubling time. Same as half-life, except we're going to have a 2 here. And we just use the letter D, but that's the same idea of doubling time versus the half-life. So if 75 people are currently infected, how long will it take for 550 people to be infected? I'm going to write out the formula the same as the half-life formula, just so you can see the similarity. So at the end, I want 550. I'm starting with 75, and my doubling time is 4 days. So solving this one, we need to divide, which gives me 7.33. We have Ben, so we're ready for log form. And then if I type that logarithm in my calculator, I get approximately 2.87. And lastly, I multiply by 4 on both sides, and I get to the nearest tenth I'm up to right here. So that rounds to 11.5. Make sure you're aware of your time period. This one is in days.